We're starting a series of videos about our water system, including our well and well pump, the pump controller, and the pressure tank manifold. In this first video, we will prepare the well casing and install the pitless adapter. Later, we'll install the well pump, connect the well to the pressure tank manifold, and finally, wire up and test the pump controller. Back in February, we had our well drilled. Our well is 220 feet deep. There is 20 feet of steel casing at the top. The remaining 200 feet is, I think, in bedrock. They first hit bedrock 5 feet below the surface of the ground. The first thing I needed to do is dig a trench next to the well casing. The trench needs to be deep enough and wide enough that I can work down there and drill a hole in the well casing 4 feet below ground level. Here I am finding the point 4 feet down on the steel casing. Drilling the hole in the steel casing took 3 or 4 minutes with a carbide tipped hole saw. We've skipped to the end here. At this point, we're nearly through the steel wall of the casing. The bit got pretty hot, so I cooled it off by dipping it in the water collected at the bottom of the trench. When I started drilling again, the bit pushed through immediately. That drill bit is gone forever. The next thing I need to do for our well is install what's called a pitless adapter. This is the pitless adapter. It's a 2-part thing. This piece gets installed in that hole I drilled in the well casing. It gets lowered down into the well casing, and then this threaded piece, half of this washer comes off too. It gets lowered into the well casing. This threaded piece goes through that hole I drilled. This gets slipped on, and then this nut is put on, and this is tightened against the well casing. There's 2 layers of rubber washer here that compress, and I don't know if you can see, but this is curved also to conform with the curve of the well casing. So when this nut gets tightened down, it squeezes those 2 rubber washers against the sides of the well casing from the inside and from the outside, and that creates a tight seal against the side of the casing. Later, I'm going to thread a fitting into here. This is threaded on the inside also. I'm going to thread a fitting in there that threads in there and then has a barbed extension out here, and another section of plastic pipe will be fitted onto the barbed fitting, held in place with pipe clamps, and that will provide water to the house. So this is attached to the well casing. This piece is also threaded, and there's a hole here. This hole is where the water to the house is going to go. This piece has a hole there which matches up with that when this slides into place. And in the bottom there's a hole, and a fitting gets threaded into here, another threaded fitting on this end, barbed here, and the 200 feet of plastic pipe that extend down into the well are attached to this. The top is threaded, but it's sealed. What's going to happen is I have a T-shaped metal handle, a tool that I'll thread in here. After I've lowered the pump almost all the way in, and the plastic pipe, 200 feet of plastic pipe attached to this part's going to be in the well casing. This part gets lowered down into place, and it slides into place like that. And then once that is firmly in place, water from the pump that's 200 feet down at the bottom of, near the bottom of the well. Water gets pumped up through the plastic pipe into this fitting here, through the hole in this fitting, through the hole in this fitting, out here to the house. Just a quick aside, before this thing was invented, the way you had to do this is in regions where we have a frost. In areas where there isn't significant danger of frost, the well casing comes up out of the ground, and there's a fitting right on, a seal right on top of the casing. The power line goes in the top, and a pipe comes out the top, and that pipe can run off to your house. Here in Maine, where that would freeze solid, you know, before Christmas, we have to have this all, the pipe needs to come up, the water needs to come up from the well, out of the well casing, below the frost line. So in the old days, what you used to do that is you dig a pit 4 feet deep here in Maine, here where I am. You dig a pit, and maybe you line it with bricks or something, or you can get a metal container like a barrel that sits there, and the well comes up through the bottom of that pit, and a line goes off to the side underground to your house, you know, 4 feet down so it doesn't freeze. The trouble with that was it would be almost inevitable that stuff would get into the pit and it would end up contaminating the well. And that was the problem, that wells could get contaminated. The magic of this pitless adapter, that's why this is called pitless, because there's no pit involved. This provides a tight seal so contamination can't get into the well. The hole through the well casing is sealed up. This opening here will actually have a pipe attached to it that goes all the way to the house, and the well cap is also sealed. So there's no way contaminants can get into the well. I should have said there that there is no way for surface water contaminants to get into the well. Now we are going to install the pitless adapter into the hole I drilled in the well casing. To do this, the two halves of the pitless are fitted together, and the T-handle is screwed into the top. A scrap of wood is inserted through the hole of the pitless adapter to lock the halves together and ensure that one half doesn't slip off and drop to the bottom of the well. Look for the brass pitless adapter to pop through the hole in the well casing at the bottom of the trench. The clamp is to keep the T centered and upright. If it were to tip to the side, it would change the angle where the pitless adapter comes through the hole in the casing. Now I'm going back into the trench to add the rubber washer and that brass nut that secure the pitless adapter to the well casing. I removed the scrap of wood I had used to keep the two halves of the pitless adapter from separating. I had held it in place with some black electrical tape. Now I'm hand tightening that brass nut. And now I'm using the pipe wrench to tighten it up further. stuck in the mud. Now I will remove the clamp that held the T-handle in place and then lift the T-handle and the inside half of the pitless adapter out of the well casing. And here is the inside part of the pitless adapter. So I'm going to take off of this for now. In a little later this afternoon, I'm going to attach this to the top of the 200-foot section of water pipe that is going to be attached, that is going to suspend the pump down in the well. And then when that's all attached, we'll start lowering it down, and then this will slide back into the pitless adapter. That's the theory anyway. Next up, I'm going to install this is the fitting that goes into the pitless adapter. This part will screw into the inside of the pitless. This is the barbed side, 1 inch diameter plastic pipe will slide onto there and be clamped in place with hose clamps, pipe clamps. And I'll use this Teflon tape to wrap around, well, this direction, wrap around the threads before I tighten them up. When you put on this Teflon tape, you want to make sure you are, is that 2? 1, 2. Make sure you're wrapping it, one way of saying it is in the opposite direction of the threads. The point is, when I screw this into the female fitting, if you were to wrap the Teflon tape the wrong direction, as you screw in the male fitting into the female fitting, the Teflon tape would tend to be pushed loose and unwrapped. If you wrap it in this direction, the Teflon tape will not tend to be pushed loose, and if anything, it will tend to be tightened up.